In my drawing right here, I have I have a sheet, my sheet main. Now, why does it say main? Well, because I use the automation to create the sheets and the views and the dimensions and everything else. So now that we have a frame of reference, let me go through the process of running that automation. So 2 years ago, I created a little program, and some of you may have seen this before and maybe not, but it is a tool that I created, an add-in, called the LSC, or the Launch System Configurator. And this was my attempt at creating a demonstration project of being able to quickly create a configuration of a rocket to put a payload into space. Okay, so what are my payload parameters? I apply that information. And then where do I want to put this rocket? Do I want to put it in low Earth orbit? Do I want to go to the moon? Do I want to go to Mars? Whatever the case might be. I just simply identify that criteria of what I'm trying to build, and I can hit accept. And then from there, it's going to present me with all the configurations that meet that criteria. So I have 4 different options here based upon its price of what I want to do. So I'm going to just select the Falcon 9 here. I'm going to build that. And then it's going to build that rocket for me, and then I'm done. So now that I have a configuration, I have a model that I want to use, I'm just going to save this and give it a logical name. And where do we want to put this? We're going to put that into here and right here. And I'm going to call this Falcon 9. Falcon 9. All right, now that I have an assembly and I have it named, I have a simple little rule here to create a drawing. And if I go into here, I'm going to show you what the code on this rule looks like real briefly here. And essentially, because of the nature of how files are related to one another, there's a particular concept that you need to implement in order to go from one file. So I have an Inventor file that I'm working in, and that's this assembly. And what I want to do is I want to go and I want to find my drawing template that I want to use. And I want to gather information from my drawing template, bring it back here to my assembly in order to continue the process of creating the drawing itself, naming it, and then saving it to a particular file location. So that's essentially what this code is doing. Is I'm going to go out, this line specifically right here, I'm going to go find my drawing document, and I'm going to open it up. And then once I do that, I'm going to run a rule inside of that drawing document called save copy as, which is then going to take that template, save it to a particular location, and give it a particular name. And then it's going to come back and it's going to close that drawing. Okay, so what does that look like? Let me run that, and I'll show you what that does. So if I do that, it's going to ask me, well, what template do you want to use? So I'm going to use my, actually, I'm going to go in here. I'm going to use my LSC template because it has logic in it that I want to leverage. And I'm going to select open, and it's going to go through the process of saving that and naming it. And then it's going to prompt me, well, do I want to open up that drawing right now? Yes, I do. So now that I do that, you're going to see that I have the Falcon 9 DWG open up. So it copied the template, gave it a name, and then saved it in a particular location. And you'll notice that I only have a single sheet here. There's no views, there's no border, there's no title block, there's nothing else here. Just it's given me a start point, okay? And then I have this logic here that allows me to go through the process of creating my sheets, adding different views, and component visibility, and so on and so forth. So let's start this off. So I'm just going to run this, and I have these rules linked together. So it goes through the entire process of throwing down a border, creating some views, adding some dimensions, adding some balloons, throwing down a parts list. It's going to do all that for me based upon the information that is in the assembly model of the Falcon 9. So there are my views and the parts list, even some balloons, and then it's going to place the dimensions. And now it is complete, okay? So how did I do that? How did I make that? How did I create a view, scale it, position it, and then create another view next to it that has a detail view associated to it? How did I get that view on the far right of a shaded view? How did I scale that and locate that? How did I create a parts list and making sure that all those components, the part number and description is there? How did I, lay down the balloons? How are they perfectly aligned? Well, all that is handled with the logic. None of this is manual whatsoever. However, in order for me to do that, I had to understand what does it take in order to do that manually. If as an end user, what do I have to do to place views, scale them, position them, so on and so forth. Now, those of you that have attended any of my other previous webinars knows that I love to leverage the Inventor API. That is by far the fastest and most robust way of developing Inventor automation. Now, granted, these rules, this logic that I have here inside of this drawing, they're iLogic rules, but as I crack these open, and I'm going to go into this first one, you're going to notice that there is literally very little iLogic code in here whatsoever. This is all Inventor API code, okay? So what does it take in order to create the sheets inside of a drawing? How do I automatically do that? Okay, well, I need to identify, well, how many sheets do I need? Do I need 1 sheet, 2 sheets, 5 sheets, whatever the case might be? Well, what is the sheet size? So I also have to identify, well, what size do I want my sheet? Is it A size, D size, C size? Is it a metric measurement in terms of my sheet size? So you can access that through the drawing sheet size enumerator inside of the Inventor API. So all this information is available. It's just a matter of understanding what you need to do in a particular order in order to accommodate that. So first, I need to understand how many sheets I need. Then I need to understand what size sheet do I need. And then in order for me to do anything in terms of naming those sheets, what I'm doing is I'm just doing a loop here of however many sheet count, how many sheets I want to create. So if I want 5 sheets, all I have to do is keep adding sheet names to this to this collection right here. So it's simply copy and then paste, and I can create another one, and then whatever I want to name it. So if I want to name it anything particular, I just can come in here and just type in the name I want that sheet to be, okay? So as I add these sheet names to the collection, I'm just using that collection count for my limits for my loop. So I always want to start with 1, but if I have 5 sheets identified here, then it's going to go from 1 to 5. So I don't have to, inside of the code, I don't have to define it's going to be 5 sheets. I just have to give my sheet names here to this list or this collection, and it's automatically going to understand just based upon the code architecture, And I've expressed this in a number of my other webinars, is when you create code for your rules, or if you're using an add-in or whatever, you always want to try to keep your code as generic as possible. And this really goes back to scalability. Like if I want to scale this, I want to do more with it, I don't have to rewrite 100 lines of code. I just need to add a little bit of information or remove a little bit of information, and my code is going to work the same way every time, okay? So I have a loop to create the different sheets, and then of course name the sheets. And then I'm going back, as now that I've created the sheets based upon this list up here, I want to go back and I want to delete sheet number 1 because that's not important. However, other ways that you could potentially do this is you could get sheet number 1 and just rename that to be main, and then if there's any additional sheets you want to create, you could just add them to the list. So that's another way. And then once I have those sheets created, I delete sheet number 1, and then I go back and I activate the first sheet because I want to have a starting point. I need to have some location defined as where am I going to start this process. So this is a way of a method in order to activate a particular sheet. And you could use this method a number of different times throughout your process. Say, for instance, I need to start adding views to a second sheet or a third sheet. It's simply just using this method and then saying, okay, I want to activate that particular sheet. I can feed that in as a variable, and it's going to activate that particular sheet. And then once I do that, then I'm going to add my title block and my border. And then once that's all complete, then I'm going to go to the next rule. So why am I identifying another rule to run? Well, and this goes back to just best practices in terms of writing your code. Me personally, and quite honestly, from my experiences working with companies, it's always better to have many small rules as opposed to a few rules that are very, very complex. Now, there's nothing to suggest that you couldn't, have one big rule that creates the sheets, creates the views, creates the parts list, creates the balloons and dimensions. However, when it comes to debugging or maintaining the code or scaling the code, it becomes a little bit more challenging to identify different locations within the code. So I always try to break them down based upon their function. In this case, this rule only creates sheets. Once I have the sheets created, then I can go to the next step. And that's why I'm calling this rule right here. Once this is completed, go to the next rule to add the views. Now, I could also do some error handling in here to do a try catch. So I'm going to try this, but if there's an error, then it's going to prompt me. And that way it doesn't go to the next rule unless it's successful. But I'm fairly confident that this code works well. I haven't experienced any issues, so I don't need to do any error handling in that regard. So that's why I'm immediately calling the next rule add views.